let's go through step by step what we have on these on the quiz. Yes, Mike. No, we're going to go over the lesson now. When we get done, you can scooch out of here. We're going to have to get a little creative with going over the quiz. I have, we always give it 3 copies. I didn't save A as a PDF, and I don't have the time to really go over it right now. So, realign. Okay, so the first question is of a triangle that we have here. And what kind of triangle is this, guys? It's a right triangle. What do we always do when we find the right angle? What's that? Yeah, we make an arrow across to this side, and we label it the hypotenuse. That makes these 2 guys the legs. And as I look at this, this is x, this is 15, and this is 17. So I hope you remember the Pythagorean theorem. Does anybody remember what that says? Alan? Justice, help me out. That's right. Now, if you don't have that to start with, number 1 is just a matter of eeny, meeny, miny, mo. You're just going to guess. But if you have that to start with, you're in good shape. It's so important to draw the arrow to the hypotenuse so that we know where the 17 goes. It doesn't matter where the x and the 15 goes. So that gives me x squared plus 15 squared is 225, and 17 squared is 289. Yes?
With that, I didn't really guess, but I didn't do it that way. I used paper and just see if it went half light. It couldn't be.
Oh, you got pure luck. Yeah,
so
pure
I
luck.
did that.
All right, minus 225. Alan, the noises are not good.
I'm me.
Okay.
I'm gonna take responsibility.
X squared is 64, square root both sides. X works out to be 8. Okay? All right, so that's the first question. And most people got the first one right. So you guys did a nice job on number 1. Number 2 is a question that I was hoping we would do better at, but there's kind of a trick in it. And I was afraid that the trick might trip some of you up, which it definitely did. And by showing you the trick today, hopefully as we go through the next couple of days, we don't repeat the error that we had here. Look, I have 4 to the 8th over 4 to the negative 4. The base has to be the same, so I hope you realize it's going to stay 4. Of course, all the choices have a 4 there, so that suggests it. But what do we do to those exponents? Subtract them. Did you say divide? Yeah, no, we have to subtract. Whenever we divide what we call a monomial, like 4 to the 8th and 4 to the negative 4, we subtract exponents. So I get 8 minus negative 4. Circle agregar, 4 to the 12. Okay? When you minus a negative, you actually add. So it comes out to be 4 to the 12. Very quickly, everybody, try this one. 5 to the 3 over 5 to the negative 2. What would you get on that one? 5 to the 5. Good. Okay, definitely don't divide. You want to subtract those exponents. Number 3. Can everybody take your pen and put it on letter B? All right? Put your pen right on letter B. Ready? Now, I want you to move it 4 places to the right and down 5. If you move it 4 places to the right and down 5, you end up exactly where this dot is. So the question is, what is the coordinate of this dot? It's going to be 0, negative 4. Okay? And last but not least, number 4. 8 times 10 to the negative 3 times 4 times 10 to the 9. And I'm going to multiply coefficients, so 8 times 4 is 32. Add exponents, negative 3 plus 9 is 6. And a few people left the answer looking like that, but there's a problem. See, the last words in this say to express the answer in scientific notation. What's the problem here?
Yeah,
It's what? Yeah, it's not in scientific notation because 32 is bigger than 10. So I have to divide by 10 here. We did a lot of this early in the year. You guys were great at it. So I think that by reminding you of it now, your memory will get jarred and you'll be great at it. So if I divide by 10 with the 32, I got to multiply by 10 on the right to balance it out. So that gives me 3.2 times 10 to the 7. Okay? So I think as you look at this, nothing on this is overly difficult. And I think that showed because there were a lot of people who got 50s on the quiz and a pretty good number that got 75. And this is the first quiz. And a lot of this material is review material from a while ago. So I wouldn't worry too much about it. Just study it over a little bit tonight, and then you should be set for tomorrow. Okay, now let's take a look at today's Do It. And the first question says 3/4. I know it looks like 34 here, but that's just the nature of the beast. 3/4 x minus 1 equals 9. What do I do to start this? Right, what do I do to start, guys? Pretty simple here. Elizabeth?
You subtract, add the 1.
Add the 1, good. So I add 1, and I get 3/4 x equals 10. And then I'm going to multiply by 4/3. And that's the step that I wasn't sure you would remember. Because we don't do a lot like that. Yes? Oh, I put 9 instead of 8? I'm sorry. Okay, so 8 plus 1 is 9. Good, thank you. Die. Now, we did a lot of these the other day, and there was one on your test, where you have to divide the 3 into the 9. This is a very common thing in the Common Core. 3 goes into 9 how many times? 3, and then 3 times 4 is 12. So the answer to this one is 12. The next one says x squared is 49, so I square root both sides. 7 is right. This is a different one. We haven't done many like this. X cubed is 8, so I'm going to cube root both sides. And that's a lot like a square root, except it's what number times itself, and then again is equal to 8. So what number times itself, and then do it again, gives you 8. 2 is right. Right, because what's 2 times 2? 4 times 2? 8. So we know we get that right. All right, here's the computer operation question. Very quickly, it's going to be 3.1 times 10 to the positive 7, because that's how many can be done in 1 second. And then it says in 4 hours. So there are 3,600, which is 3.6 times 10 to the third seconds in 1 hour, and then I got to multiply by 4. You just multiply those things and you get your answer. I don't want to really take too much time to go over that right now. We've done a lot of questions like that lately. So all you would have to do is multiply that out and see what you come up with. Okay, next, number 4, I think the final one.
No, we have 3 and 4.
Oh yeah, here we go. Which of these is quadratic? Only one of them is quadratic. We did it a little earlier in the year, and then we did it a little bit with tables too. C. First off, isn't C the only one that looks different?
Yeah.
So that kind of gives it away. But you see how it's squared here? Squared means quadratic. Whenever you have a highest exponent of 2, that's always the one that is going to be quadratic. And as far as the next one goes, there's really nothing there to do, so I don't know why I put that there. Okay, let's go to today's lesson. We're going to learn all about vertical angles. Okay, I'm going to see if it's possible to bring this up on YouTube and watch this little video here. If it's possible, only because I love our district for having given all the teachers laptops a few years ago, but they're over 5 years old now. And what happens is that the flash player that these guys can host is not working anymore. So, yeah, there we go. All right. All right, so I'm not worried about this. Not a big deal. Because I also have a slideshow on these that I made up. Vertical angles, rotations, and equality. All right, ready? Vertical angles it's very, very simple to do vertical angles. Everybody take one hand, hold it up like this. Take the other hand, hold it up like this. You just made vertical angles. Whenever 2 lines cross and form an X, like in the diagram, you make vertical angles. And these are formed by intersecting lines. What do intersecting lines do?
Lines that cross each other.
That's right, lines that cross. Very good. Okay. Now, here is the first important thing, I want you to write this down on your paper. Vertical angles are equal. Vertical angles are equal. Just put it down somewhere on your paper. Now, I actually just did a mistake. I forgot to swirl. Now, vertical angles is really the phrase of the day, the word of the day. Vertical, everybody turn to the person next to you, say vertical angles. Very good. You guys got to back off a little. I thought you were going to kiss there for a second. So it was a little strange. You guys, you invaded personal space on that one. Okay. Well, you were like, whoa, whoa. I'm not suggesting he was. He was so animated. It was like, I was like, a little bit more space. A little more space. Okay. I don't mind staring in the eyes. All right. Now,
That's weird too.
yeah, it is a little strange. Okay. Now, and then everybody do this. Vertical angles make an X.
Not doing that.
Everybody do it. Vertical angles make an X.
No.
Vertical angles make an X. There we go. Okay. So now we know what we have going there. All right. So here's a picture. Excuse me. Here's a picture of vertical angles. Do you see the angles that are across from each other, the 95 and the 95? Right? You see that? Those two angles are vertical angles. There's actually 4 angles in this diagram, if you look. We have the 2 guys that are 95 each across from each other on the left and right, but aren't there also 2 on the top and bottom? Now, the 2 95s are vertical angles. The 2 that are on top and bottom are also vertical angles. Vertical angles are always in pairs. But, watch me now, this is very important. These 2 guys are not vertical angles. So these 2 are, so they're equal. These 2 are, so they're equal. Isn't it as if I could rotate, let's do it this way, let's rotate to the left there. I could rotate this angle 180 degrees and it would land right on top?
Yep.
And since it lands on top, and it's what that word we called an isometry, it means it's the same size, same shape. So, therefore, the 2 angles are congruent. Okay. Name a pair of vertical angles in the next diagram. Tell me 2 angles that are going to be equal to each other because they're vertical. Jalen? 2 and what?
4.
2 and 4 are vertical. Very good. And there's one other pair of vertical angles. What do we have on that one there? Jeff, go ahead. 1 and 3 are vertical. Excellent. Very, very good. Remember, it's the ones that are across from each other that are vertical.
It's a cool sideshow.
Okay, now, here's the next thing, and this is very important. Sometimes they ask you to name the angles, and you should have done a lot of work with this in 6th and 7th grade. See, if I say to you, I think everybody would understand. Let's use my finger to point here. Ready? This guy and this guy are equal. Agree?
I'll agree.
All right, and those are vertical. What about these 2?
I'll agree.
Yes. The problem is that if they gave you words before this, and you know they love putting words in questions, they'll say the measure of angle AEB
Oh, I hate
is equal to which angle? So this is what I want you to do. Take your pen, put it on, oh, you can't put it on paper. Watch my finger. Ready? Here's A, E, B. This angle. What is the name of the angle that it's vertical to? What is the name that it's of the angle that it's vertical to? Lewis? What? DEC works. Good. DEC. There they are. These 2 are vertical. What about angle BEC? What's the name of the angle that's vertical to BEC? Chelsea? AED. Very good. AED. Excellent. Okay. So we have the idea of how to identify vertical angles. The question is how to name them, and we need to continue to work on that. If the measure of angle AED is 75, what's the measure of angle BEC? If AED is 75, what is the measure of angle BEC? By the way, do you see this little M in front here? Okay, see this? I think we all see angle AED. This little M in front means measure. It means how big angle AED is. So it's saying if angle AED is 75 degrees, find how big angle BEC is, the measure of angle BEC. What do we get on that, Justice? 75 is correct. Very good. Okay. Now we get into an interesting one. If the measure of angle AED is 3x minus 2, and the measure of angle BEC is x plus 48, find x. Aren't those 2 angles equal? You with me, everybody? Okay, so all you have to do is write down that they're equal. Now, you're left with an equation, but didn't we solve a whole bunch of equations like that earlier in the year? So I would just subtract the x and then add the 32 and so on and so forth. Why are vertical angles equal? Because if I spin them, they land directly on top and then over to there. Okay? So that's why vertical angles have to be equal. The rotation produces vertical angles. Ta-da! Okay, so now, some classic state assessment type questions that have to do with vertical angles. Vertical angles are always equal. Another word for equal in geometry is congruent. So it says which pairs of angles are congruent? Is it S and R, T and U, R and T, U and S, T and S, U and R, U and T, T and S? Take a look at those four choices. Figure out which one is a pair of equal angles. Let's give everybody a second to catch up there. Alan, we got to pick your head up and learn, bud. Stephen, what do you think? Which of those sets are going to be both equal angles? Yeah, no, that's not going to be because they should be across from each other, and S and R are next to each other. There's actually a word for that, adjacent. All right, Chelsea, what do you got? T and S, they're across from each other. Those are vertical, good. U and R are vertical also. So those are the ones that work out to be vertical angles. Okay, next. In the figure below, angle R and S are formed by two intersecting lines. What kind of angles are angle R and S, everybody? Hey, what kind of angles are angles R and S? Oh, come on. What is the whole day about today? Vertical angles. What kind of angles are angles R and S? Vertical angles. Good. If angle R measures 55, what's the measure of angle S? Everybody? 55. Good. I don't know why that got cut off like that. All right. Now, the happy recap. What shape says two angles are vertical? What shape says the two angles are vertical, guys? What letter do you have to see? Letter X. Good. Vertical angles are always equal. What type of transformation can make vertical angles? Come on, what did you do? What did we do to get it to... We spun it. So what's the type of transformation that spins? Rotation. Very good. Okay, you can start your homework now.
Oh, geez, you should have done the lesson.
Tomorrow I think we'll talk a little bit more about taking it up a level and throwing some more equations into the mix. Today we understand that they're equal. Tomorrow we apply it just a little bit more.